Okay, in this video we're going to start talking about modulus signs. Modulus signs come up a good bit in algebra and also come up a lot in coordinate geometry of the line and coordinate geometry of the circle. It's really important that you understand what modulus signs represent. The modulus signs here are the two vertical lines. So this means the modulus of x minus 3. Something inside a modulus refers to it occupies space. It's a length, a distance, an area, or a volume. All of these things have one thing in common. They cannot be negative. You cannot have a negative distance or a negative area or a negative volume. So whenever you have a modulus, for example, if I was working out the area of a shape, sometimes depending on what quadrant the shape is in, sometimes I might get a negative value. I could carry out a question and end up with the area of a shape is the modulus of minus 16. The modulus of minus 16 is simply 16. We cannot have a negative area. So modulus signs are simply there in order to ensure that whatever you get, you take the positive value. If you have a minus 16, you simply take plus 16. And likewise, if you had the modulus of 16, that's obviously already positive, so that's grand. That would also be 16. The modulus of minus 16 is 16. The modulus of 16 is also 16. The concept here is just think of it as a distance. Like I often think of it as, let's say you had a point out here, a point on the x-axis at minus 3, 0. The distance from this point to the origin is 3. Even though this is a minus 3, to the left we refer to these as negative values, the distance is still positive. This is the point minus 3, 0, but the distance is still plus 3. So as we go through this video, we're talking about modulus and how we deal with it. Just always think of it as the modulus is something which occupies space, like an area or a volume or a distance. Okay, so let's have a look at this example first. The maths we're going to do in this video is really straightforward, but you need to understand the concept I'm talking about. Imagine I was asked to solve the modulus of x minus 5 is equal to 3. There are two different ways of eliminating your modulus signs, and to be honest, for a question like this, I don't think it really matters which one you do. I'm going to go through both of them, and then whichever one you prefer, that's the one you should go with. If I have modulus signs here, perhaps what I have inside the modulus signs is negative. Perhaps at the moment I actually have minus 3 inside the modulus sign. Or perhaps I already have plus 3 inside the modulus sign. Either way, whatever's in here has a value of 3. If the thing in here is negative, then I would have to multiply it by minus 1 to change its sign. And if I had a minus 3, I'd just change its sign, multiply it by minus 1, and I'd say, right, that value is 3. If the thing in here is already positive, then I wouldn't change its sign, which not changing its sign is the same as multiplying it by plus 1. So I just leave it exactly as it is. So one way of eliminating your modulus signs is you could say, right, well, I don't know whether this is currently a minus 3 or a plus 3. I don't know whether I need to multiply it by plus 1 or minus 1. So what you do is you simply do both. You get two different possibilities, because there's obviously two different possible values for x depending on which one of these exist. So one way of eliminating your modulus signs is simply multiplying whatever's in the modulus by plus or minus. There are two different scenarios, and either I would just not change the sign of the left, or I would change the sign of the left. I don't know which one is true because there's obviously two different possibilities here. So one scenario, one thing you can do is you can simply take plus or minus in front of the left-hand side. And when you do that now, it's very straightforward from there. What I would always tell my students to do next is to split their page in two. In one scenario, I would take this as a plus. Imagine it's plus times x minus 5 equals 3. And in the other scenario, you take it as if it's a minus. So it's minus times x minus 5, which is equal to 3. And now I've got two very straightforward equations that I can solve for x. So here I just have x minus 5 equals 3. So in order to get x on its own, I would add 5 to both sides and get x is equal to 8. On the other hand, if I was multiplying everything by minus 1, I'd have minus x plus 5 is equal to 3. What I might do next is subtract 5 from both sides, and I would get x is equal to 3 minus 5, which is minus 2. Multiply both sides by minus 1 and get x equals 2. So the two possible values for x, for which the modulus of x minus 5 equals 3, is x could either be equal to 8 or x could be equal to 2. Right, so that's your first possibility, and you can do it like that if you want. Sometimes in coordinate geometry we're going to be forced to do it like that. However, sometimes we're going to be forced to do it a different way. So you need to be comfortable with two different ways of doing it. So imagine we can completely ignore that. One possibility for eliminating your modulus signs is just taking plus or minus. However, there's another way to ensure that whatever you have is positive. If you square something, it's definitely positive. My goal is to just ensure that whatever I have in here, that I end up with something positive. So another way to eliminate your modulus signs is to simply square it. If I get x minus 5 squared, then I can eliminate my modulus signs. Because I know that, let's look back at it. The possible things that I could have in my modulus signs at the moment are either minus 3 or plus 3. If I square minus 3, it's definitely positive. If I square plus 3, it's definitely positive. So either way, I'm definitely ensuring that whatever I have in my modulus signs is positive. So the second way of eliminating your modulus signs is simply squaring it. But I can't just randomly square the left-hand side. If you're going to square the left-hand side, you obviously also have to square the right-hand side. So if you multiply x minus 5 by x minus 5, obviously it'd be the first thing in the first bracket by the second bracket, second thing in the first bracket by the second bracket, and so on. You'd end up with x squared minus 10x plus 25. And 3 multiplied by 3 gives me 9. Here I have an x squared, I have an x, and I have a number. So I clearly have a quadratic equation. So what I would do next is subtract 9 from both sides and get x squared minus 10x plus 16 equals 0. And now I'm in a position to factorize it. So what I can do now is I just get x minus 2 times x minus 5. Once I have the two factors, I can just add each factor equal to 0 and find the roots. So I could say that x minus 2 is equal to 0, which means x equals 2. Or I could say that x minus 8 equals 0, which means that x is equal to 8. So the two possible values for x in this scenario, once again, are working out as x equals 2 or x equals 8. Okay, but there are some questions that, as far as I'm concerned, it's really clear-cut which method you should use to eliminate your modulus signs. In this case, I have the modulus of 4x plus 7 is less than 1. If you have an inequality and a modulus, square both sides. It is so much easier. Square both sides. Do not take the plus or the minus. I actually think that in example 1, it's probably easier with the equation to just take the plus or the minus. It is definitely not in this scenario. You should square both sides if you have a modulus and an inequality. Let's just go through this question. I have 4x plus 7 is less than 1, which would be a very straightforward question if not for the fact that the modulus signs are there. So in order to eliminate the modulus signs, I'm going to square both sides. I can now say that 4x plus 7 to be squared is less than 1 to be squared. You have to square the left and square the right, and I can more or less just ignore the fact that there was modulus signs at the start. If you multiply 4x plus 7 by 4x plus 7, you're going to get 16x squared plus 56x plus 49 is less than 1. Obviously, you have to multiply that out, 4x plus 7 by 4x plus 7. You should drag it out, and you should make sure you get to here. What I would do next is I would subtract 1 from both sides and get 16x squared plus 56x plus 48 is less than 0. Now, hopefully you'll recognize where we're at this stage. I have a quadratic and an inequality. In order to answer the question posed on this line, I need to let it equal to 0. I need to factorize and solve it and sketch my quadratic curve, just like we did in a number of videos previous to this. So for the moment, I'm going to ignore the fact that there's an inequality there, because what I want to do now is I want to sketch my graph. I can clearly see that that 8 divides into each of my terms here, so I can divide everything by 8 to make my quadratic a little bit more achievable. 16 divided by 8 is 2, 56 divided by 8 is 7, and 48 divided by 8 is 6. What I can do now is I can simply factorize my quadratic. If I was to factorize this, I would end up with 2x plus 3 times x plus 2 equals 0. And I can just let each factor equal to 0 and I can find the corresponding roots. So I can say that 2x plus 3 equals 0, which means 2x equals minus 3, so x is minus 3 over 2. Or I can say that x plus 2 is equal to 0, which means that x is equal to minus 2. Remember that the whole point of doing that was so that I could sketch a quadratic. I now know that this is a plus x squared, and I'm well aware that a plus x squared is a U-shape. And I know that my quadratic crosses the x-axis at minus 1.5 and at minus 2. Again, there's no marks going for the graph, so it doesn't need to be accurate. It just gives us a better idea of what's going on. I could say that this is minus 2 and that this is minus 1.5 or minus 3 over 2. And once I've drawn my graph, I'll go back to the last line that I had in inequality. This line reads as when is the quadratic less than 0? The quadratic is less than 0 when it's below the x-axis. Below the x-axis is clearly all of the x values between minus 2 and minus 3 over 2. It's one continuous region, which means I need to give one answer. So I can now say that x must be to the left of minus 3 over 2, or in other words, less than minus 3 over 2, and to the right of minus 2, or in other words, greater than minus 2. So my final answer here is that when x is greater than minus 2, but less than minus 3 over 2, then the modulus of 4x plus 7 is less than 1. So that's my final answer for this one. You'll notice now that a lot of things that we looked at the start of the topic are cropping back up. It's really important that you're clear, that as we go through each topic, you're really clear on all the things we've done prior to it. So they're the only two examples I'm going to do in this video. What I want you to do now is I want you to attempt a number of questions involving modulus signs. So I'm just giving you 3 questions to try here. The first one, you have to solve the modulus of 3x minus 2 equals 19. In that case, you can take plus or minus in front of the left-hand side, or you can square both sides. Since one of the answers is going to be quite awkward, it's going to be far easier there if you take plus or minus in front of the left-hand side. However, I think it's worth our while. I want you to try that question by 2 different methods. Question 2 says find the range of values of x for which the modulus of 2x plus 1 is greater than or equal to 9. If you have a modulus and an inequality, as far as I'm concerned, it's clear cut. You square both sides, it's far easier. And in question 3, I want you to solve the modulus of x minus 2 is equal to the modulus of 2x minus 1. We haven't looked at one of those. I want you to follow your instincts there and see if you can figure out what to do with that. So I want you to pause the video now and try the 3 questions and then compare them to my solutions. Okay, we're going to solve question 1 by 2 different methods. The first method here is to get rid of the modulus signs. I can just take a plus or a minus in front of what's in the modulus. So I could have plus 3x minus 2 equals 19, or minus 3x minus 2 equals 19. And both are very straightforward. We end up with either x equals 7 or x equals minus 17 over 3. Let's have a look at the other way that we could have solved this question. The second scenario is, in order to eliminate the modulus signs, I could have squared both sides. If I square 3x minus 2, I just write it as 3x minus 2 squared, but I also must square the right hand side, which becomes 19 squared. If you multiply 3x minus 2 by 3x minus 2, you get 9x squared minus 12x plus 4, while 19 squared is 361. I have an x squared, an x and a number, so I decided to subtract 361 from both sides, and I got 9x squared minus 12x minus 357 equals 0. Divide both sides by 3 and get 3x squared minus 4x minus 119 equals 0. This one is kind of tricky from here because obviously it's hard. I think it's relatively difficult to find those factors. Obviously what you could do is at this stage you could use the minus b formula if you want, but just in this case the factors were 3x plus 17 times x minus 7, and you end up with the same answers as we got the last time: x equals minus 17 over 3 or x equals 7. In a question like that, just be aware it doesn't matter which method you use. Sometimes one method will seem easier than the other, but it really depends on the question and it depends on the context of what you're being asked to do. So I think you just need to be comfortable to do both. In question 2, we have a modulus sign and an inequality. As far as I'm concerned, there you should square both sides. It's by far the easiest thing to do. If you square 2x plus 1, you get 2x plus 1 to be squared. The right hand side just becomes 9 squared. If you multiply out your brackets, you get 4x squared plus 4x plus 1 is greater than or equal to 81. When I manipulated this around, I ended up with 4x squared plus 4x minus 80 is greater than or equal to 0. At this stage, I have a quadratic equation and an inequality. If I have a quadratic equation and an inequality, I need to just ignore the inequality, let my quadratic equal to 0, factorize and solve it so that I can sketch my graph. So that's exactly what I've done. I let it equal to 0 and I realised then that I could divide everything by 4 and get x squared plus x minus 20 equals 0. When I factorised and solved this, I got x equals minus 5 and x equals 4. So I know that if I graph this quadratic, it crosses the x-axis at minus 5 and it crosses the x-axis at 4. It's a plus x squared, which tells me that it's a U-shape. And now that I've drawn a sketch in my graph, I go back to this line that I've starred. I go back to the line where I have a quadratic and an inequality. I want to know, when is this quadratic greater than or equal to 0? The quadratic is greater than or equal to 0 when it's above the x-axis. The quadratic is above the x-axis to the left of minus 5 and to the right of plus 4. Clearly this is two separate regions, which means I need to give two separate answers. To describe values to the left of minus 5, in this case it's x is less than or equal to minus 5. I include the equal to because there's an equal to in the original question. To describe values to the right of 4, it's x is greater than or equal to 4. Once again, I'm including the equal to because it's in the question, and there's no reason for me not to include the equal to sign. So in that case, I actually get two different ranges of values for x. So that's what you need to do for that type of question. Let's have a look now at question 3. Okay, in question 3, we're asked to solve the absolute value of x minus 2 is equal to the absolute value of 2x minus 1. We didn't come across one of these in the examples, although it could come up somewhere along the course. Again, there's two different ways of doing this. If you decide to take the plus or minus option, you can just take plus or minus in front of one of the sides, and it doesn't matter which one. I could just simply take plus or minus in front of the left and that would eliminate all my modulus signs. Or I could take plus and minus in front of the right and that would also eliminate my modulus signs. So the first way we might do this is with the plus or minus. What I'm going to do is I'm going to simply take plus or minus in front of the left hand side. And I can let it equal to 2x minus 1. All the modulus signs are gone if I do that. And once again, in order to finish this question off, I would simply split my question in two. In one scenario, I could say that it is plus times x minus 2 is equal to the right hand side. And in the other scenario, I could say that it is minus times x minus 2 is equal to the right hand side. And now I'm just going to solve both of these relatively straightforward equations. So it's relatively straightforward from there. If I take the plus on the left hand side, it's simply plus times x minus 2 equals the right hand side. What I decided to do was move all my x's to one side, numbers to the other side, and I ended up with x equals minus 1, and that's my first possibility. But there is another possibility, where if I multiply the left hand side by minus times x minus 2 is minus x plus 2. I could move all my x's to one side, numbers to the other side, and in that scenario I end up with x equals 1. So that's one possible way of solving this question. But let's have a look at the other possible way, where the other scenario I could simply square both sides to eliminate my modulus signs, and I should end up with the same answers as I'm getting here. So the alternative is I could have just squared both sides to eliminate my modulus signs. So I get x minus 2 squared equals 2x minus 1 squared. If you multiply x minus 2 by itself, you'll get x squared minus 4x plus 4. While if you multiply 2x minus 1 by itself, you'll get 4x squared minus 4x plus 1. I realise now I have x squareds, x's and numbers, so I clearly have a quadratic equation. So I decided to move everything to the right hand side, and in that case my x terms actually cancelled each other out, and I ended up with 3x squared minus 3. So at this stage, I decided to divide both sides by 3, and I got 0 equals x squared minus 1. X squared minus 1 is the difference of two squares. So I can write that as x minus 1 times x plus 1, and I let each factor equal to 0, and the two possible values for x are x equals minus 1 or x equals plus 1. So I got the exact same answer as with the plus or the minus. So in a lot of cases, it doesn't really matter, but just be aware, you need to be comfortable with both of them, because in some cases it does matter which one you use. Now, in the next video, we're going to continue to talk about modulus graphs. We're going to discuss how you could actually draw a modulus graph on a coordinate plane.